Hello everyone! In this lesson, we'll learn the integration of FANUC industrial robots and within devices together. First, let's learn the basic principles of within devices. There are two kinds of workpieces with different shapes and size, reducer and flange. Since the quality of the reducer and the flange is very close, it's necessary to use the within device to distinguish them by weight. The weighting device can convert different masses into analog voltage signals. The analog voltage signals are input to the backflow I/O module and continue to be converted into digital quantities. Then, the corresponding digital quantities are sent to the robot through the DeviceNet network. The robot can determine the workpiece's type on the current within device according to the different signal quantities, thereby realizing sorting. Next, please answer this question. In the integrated application of FANUC industrial robots and within devices, how does the within device transmit the quality information of the workpiece to the robot? A. Transmit directly to the robot through wireless signals. B. Convert the mass into an analog voltage signal. Convert into a digital quantity by the backflow analog module and then transmit through the DeviceNet network. C. Transmit through USB interface connection. D. Transmit the digital signals directly through Internet. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. First, let's learn the working principle of the within device. Its main internal component is the loaded cell. The loaded cell uses a metal resistance strain gauge to form a measurement branch. When the metal resistance wear in the finger elongates and becomes thinner under the action of gravity, its resistance value will increase, and the voltage between UABs in the finger will change. The magnitude of the change in voltage value reflects the magnitude of gravity. The load cell measures the weight signal by attaching the metal resistance strain gauge to the metal within beam. Next, please answer this question. What are the main components inside a within device? A. Photoelectrical sensor. B. Displacement sensor. C. Load cell. D. Temperature sensor. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Next, we learn the calibration of analog input signals of FANUC robot. First of all, we need to calibrate the digital quantity obtained by the robot. Thus, convert the digital quantity into quality, which is of practical significance. The method is using a standard block with a known quality to perform a linear calibration on the mirroring range of the within device and convert the measured data into the mass unit gram. Specific steps are as follows. First, record the analog reading when the tree is empty. Second, place 1 yuan coin and record the analog reading. Third, place 4 yuan coins and record the analog reading. 4. Calculate the conversion relationship between the analog quantity change value and the mass according to the data obtained in steps 1 to 3. First, let's look at the configuration of the input analog signal. As shown in the figure, the rack number of AI1 to 4 is 82, the slot is 12, and the channels correspond 1 to 4 respectively. Next, let's implement the calibration of the within module. First, check the value of analog input signal AI3 used by the within module. The value of AI3 in the figure is 2288, and the display values of different devices are slightly different. Second, put 1 yuan coin in the tray and check the teaching box. After the value is basically stable. Now, the indicated value of AI3 port is 2496. Third, put 4 yuan coins on the tray and check the teaching box again after values are basically stable. Now, the indicated value of AI3 port is 3080. Fourth, the analog difference between 3 yuan coins is 3080 minus 2496 equals to 584, and the corresponding analog value per gram is 32. The conversion formula for analog data and workpiece quality is as follows. 5. Create a new 称重 program R4 equal AI1 minus 2288. Divide 32 and set the program to run in the background. Then place the reducer workpiece into the within module tree and view the value of R4 from the monitoring window of teaching box variable. 6. Test all reducer and output flange workpieces and record all data. It can be seen from the data analysis that the workpiece mass of the reducer is about 21.9 G and that of the output flange is about 21.4 G. You can use 21.7 as the boundary. If the value is greater than this value, it means that the workpiece is the reducer, and if the value is less than this value, it means the output flange. Next, we can implement weight-based workpiece sorting on the robot side. The main idea is to use a mass value. For example, take 21.7 grams as the cutoff point. If the mass of the workpiece in the weighing device is greater than this value, it's a flange. If it's less than this value, it's a reducer. Next, please answer this question. Which of the following is not a mere step in achieving weight-based workpiece sorting? A. Perform quantity conversion on the calibrated analog signal. B. Set quality cutoff point in the robot program. C. Identifying workpiece taps by using vision sensors. D. Perform corresponding picking and placing operations according to quality judgment results. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Now, we give the main program statements. First, add if and else instructions. Add the judgment statement R4 larger 21.7 here if the if instruction. That's to say, if the workpiece mass is greater than 21.7, then it's a flange. After the industrial robot picks up the flange at the weighing device, it will be placed at the fixed flange workpiece placement point. On the contrary, if the workpiece mass is less than 21.7, then it's the reducer. After the industrial robot picks up the reducer at the weighing device, it's placed at the fixed reducer workpiece placement point. In this lesson, we learned about the integration of FANUC robots and with devices and understood the weighing principles and signal calibration and sorting implementation. Through analog signal conversion and quality calibration, the weight-based workpiece sorting is realized. That's all for this lesson. Thank you for watching.